Arithmetic. Arithmetic is the most basic branch of mathematics and the starting point for all other areas of math. It deals with numbers and the four fundamental operations: addition, subtraction, multiplication, and division. Whenever you count money, calculate your expenses, measure ingredients while cooking, or determine how much time is left before an event, you are using arithmetic. It teaches us how numbers behave and how to manipulate them in simple but powerful ways. Without arithmetic, more advanced mathematical concepts would not be possible because it forms the foundation upon which everything else is built. Algebra. Algebra builds on arithmetic by introducing symbols and letters to represent numbers, especially unknown values. Instead of solving problems with only visible numbers, algebra allows us to solve equations like x plus 5 equals 10 and find the value of x. It helps us describe patterns, relationships, and rules in a general way, rather than solving just one specific example. Algebra is extremely important in science, engineering, economics, and technology because it allows us to model real-life situations and predict outcomes. It turns numbers into a language that can explain how different quantities relate to each other. Geometry. Geometry is the branch of mathematics that studies shapes, sizes, angles, distances, and space. It focuses on objects such as triangles, circles, squares, rectangles, and three-dimensional figures like cubes and spheres. Geometry helps us understand how space is structured and how objects fit within it. Architects use geometry to design buildings, engineers use it to construct roads and bridges, and artists use it to create balance and symmetry in their work. It allows us to measure land, calculate areas and volumes, and understand the physical world around us in a visual and spatial way. Trigonometry. Trigonometry is a specialized branch of mathematics that focuses on the relationship between angles and sides of triangles. It introduces concepts such as sine, cosine, and tangent, which help calculate unknown sides or angles in a triangle. Although it begins with triangles, trigonometry is widely used beyond simple shapes. It plays a major role in navigation, astronomy, engineering, and physics. For example, it helps determine distances that cannot be measured directly, such as the height of a mountain or the distance to a star. Trigonometry allows us to make precise calculations involving angles and motion. Calculus. Calculus is the branch of mathematics that studies change and motion. It helps us understand how things grow, move, and vary over time. There are two main parts: differential calculus, which focuses on rates of change like speed and acceleration, and integral calculus, which focuses on accumulation, such as finding areas under curves or total quantities. Calculus is essential in physics, engineering, economics, biology, and medicine. It explains how planets move, how populations grow, how heat flows, and how machines operate. Without calculus, much of modern science and technology would not exist. Statistics. Statistics is the branch of mathematics that deals with collecting, organizing, analyzing, and interpreting data. It helps us make sense of large amounts of information by summarizing it into meaningful conclusions. When researchers conduct surveys, governments analyze population data, or businesses study customer behavior, they rely on statistics. It allows us to calculate averages, measure variation, and determine trends. Statistics helps people make informed decisions based on evidence rather than assumptions, making it a powerful tool in research, medicine, economics, and public policy. Probability. Probability is the branch of mathematics that studies chance and uncertainty. It measures how likely an event is to happen using numbers between 0 and 1, or percentages. For example, the probability of flipping a coin and getting heads is 1/2. Probability helps us understand risk and make predictions in uncertain situations. It is used in insurance to assess risk, in weather forecasting to predict storms, in finance to manage investments, and in games to calculate odds. By studying probability, we learn how to make logical decisions even when outcomes are not certain. Number theory. Number theory is the branch of mathematics that focuses on whole numbers and their properties. It studies topics such as prime numbers, divisibility, factors, and patterns within integers. Although it may seem simple at first, number theory contains some of the deepest and most challenging problems in mathematics. It plays a crucial role in modern encryption systems that protect online communication and financial transactions. Number theory shows that even the most basic numbers can hold complex structures and hidden patterns that mathematicians continue to explore. Linear algebra. Linear algebra is the branch of mathematics that deals with vectors, matrices, and systems of linear equations. It provides tools for handling multiple variables at the same time and organizing large sets of numbers efficiently. Linear algebra is fundamental in computer science, artificial intelligence, physics, engineering, and economics. It is used in computer graphics to create 3D images, in machine learning to train algorithms, and in physics to describe forces and motion. This branch of mathematics makes it possible to solve complex problems involving many interconnected quantities. Discrete mathematics. Discrete mathematics studies mathematical structures that are separate and distinct rather than continuous. It includes topics such as logic, graph theory, combinatorics, and algorithms. Unlike calculus, which deals with continuous change, discrete mathematics focuses on countable objects like integers, networks, and sequences. It forms the foundation of computer science and programming because computers operate in discrete steps. Discrete mathematics helps design efficient algorithms, secure communication systems, and network structures. It is essential for understanding how modern digital systems function.